Hi, this is Paul again. Now I'd like to introduce you to part 1 of DNA Swirls. I am starting this new set of videos so that I could focus on the DNA using this 5-cube vector system. This very important discovery was made when I was working on my last video. Okay, in front of you I show a yellow cube picking up 8 vertices of a dodeca. Now we'll bring in a red cube. There's a 44.6 degree difference in the two cubes around the same axis, and a perfect golden ratio can be found between the two edges, the yellow and the red. What's amazing about these two cubes is that the two colored cubes only produces one vector at the shared vertex points. Notice that I've made the vectors red and yellow so that it corresponds to the two cubes. Okay, now I'm bringing in a cyan cube, and the cyan yellow should give us one vector, and the cyan and red should give us another vector. Okay, now we'll bring in a green cube. So we have a green and a cyan to start, and we also have a green and a red vector, and we have a green and a yellow vector. Okay, that gives us 6 vectors for 4 cubes. That sounds right, 6 doubles for 4. So now when we bring in the 5th cube, which is a purple one, we should get 10 doubles. So we got purple and green to give us number 7. We have purple and yellow, which is number 8. And we have purple and cyan, which is number 9. And we only got one left, and that should be a purple and a red. And that will give us 10. But these 10 vectors all go to the center. So actually there are 20 vectors. I showed in my previous videos that DNA can go in one vector, and it is possible to make a bend in 9 other vectors. So the DNA could go in any of the 20 vectors and come out 9 bends and a straight. It would probably make a good math permutation. Okay, while we're at these scenes, it's a good time to show you the DNA bend angles. We have 138 pico for the top 3, and we have 109 pico for the second 6. I showed in my early video that the DNA swirls would only take bends in these obtuse angles. I also showed that it wouldn't go on an acute angle, and it acted just like a check valve. Okay, so now I think we'll show you the very importance of these vectors. Let's start with our very first bend. We'll give it a couple of rings and we'll call it V1, vector 1. Note that it is the first of the top 3 vectors. So now we'll move it around a little bit and we'll bring the next vector of this chain. So this red and green vector will be vector V2. So now we'll bring in our third vector. Now notice that this green and yellow vector makes the 75.4 gap on the dodeca from the last vector. Notice these last 2 vectors came from the white ring, which contains 6 vertices. Okay, now we've achieved the first 3 vectors of the 9 vector DNA system. But this setup isn't completed until we add another dodeca. This dodeca doesn't do a bend, but it rounds off out of the golden ratio state. It adds another 44.6 to the 75.4 to make 120. It was a bit of a mind boggler actually, but I'm going to bring in the swirls now and show you how it all goes together. First of all, let's have a look at the swirls going around the dodecas and picking up the vertices as it goes around. The bottom ball and the top ball haven't got a vertex because the dodecas are not shown. Okay, I'm going to take away the dodecas now and you can see the swirls as they move down. I think we now have the correct angles for the swirls for A-type DNA. Okay, let's take a look. Our first swirl is a red swirl, and this turns 60 degrees. And our next swirl is a green swirl, and that one again is 60 degrees. Now our next swirl is different. This is the blue swirl, and she's 75.4 degrees. It bridges across the wider gap on the dodeca. Now we have one more swirl, and this is a 44.6. Now if you add that to the 75.4, we got 120. I showed that 44.6 giving us the golden ratio in the cubes earlier on. This probably produces a golden ratio measurements between the swirls that they found on YouTube. Okay, we'll take this section and we'll zoom out and bring back the dodecas, and we'll start adding to this section to make a new string. I'm moving up in 4 steps of 173 pico. This is because I'm all set up for this. When I get to the top, I rotate by 240 degrees. This could keep going on forever, but I'm only going to 3 steps, which is a full section. Okay, now I'm going to change the view to the top view and put this animation, and you're going to see something good. Okay, now you can see as each of these sections are added and rotated to the correct position, it's possible to number the exact sequence of these vectors. This shows a spectacular order of the vectors as the DNA goes around. I show a copy of the first 3 vector colors. Actually, this wasn't so confusing. So now I can keep them numbers, and I'm going to bring the correct color arrangement of the vectors in. Okay, now we're back to the original color settings. Note that this is not flat, because we're looking at 3 vectors on a top plane, and we have 6 vectors on the second plane. V1, V5, V9 makes 15. Check the other ones. I'll rotate this back to the front view again, and I'll bring back the bottom 10 vectors. Okay, what I've done, I've converted this to a flat control panel. Okay, you see the top 10 vectors and the bottom 10 vectors have all been given numbers for the colors, 1 to 5. I show 20 buttons. I think they could be used for computerized control for moving the DNA around. I think this control will be the same for every dodeca in the DNA system. It could be described as the DNA 3D network. In the future, you'll probably find YouTube. I would say this number configuration of vectors, and the last one, I'll bring it back again. It's got a big future with somebody that likes to do programming and good at maths. Okay, so now we'll leave all these vectors and let's get back to the swirls again. Okay, we'll start by running up and down a straight basic section of this DNA. I've added a 44.6 swirl so that the bend has got a bit of leeway. Okay, now we can go into the V1. That will be our first bend. Okay, we'll take it up with the dodecas, and we'll come back just using the swirls without the dodecas. I've made the bend swirl, which I call a spago. I've made it red and white. Now we're starting to make the second bend. This will be the V2. Actually, it took me quite a while to get the sequences right so that the bends would run perfect. I'm pretty sure that I've got the geometry correct now, because the bends are going pretty smooth. You can kind of tell if the curve is not going correct, and then it's time to rearrange the geometry. Okay, finally we're going into the V3 bend. This will be our last bend to worry about, because it completes the section, and as you can see, she's flowing beautiful. So it's basically pretty simple. With 4 swirl pieces and 3 spagos, we have the basic pieces so that the DNA will move any way you want. In my earlier video, DNA Fundamentals, I showed what could be done with just 3 ways. Now imagine what can be done with 9 different ways. So I hope all this has been of interest, and this is Paul saying thank you very much for looking at my video.